Let's look at how to solve radical equations. Today we're going to look at two types of radical equations. A one radical problem and a two radical problem. All right, so for each one of those, the steps really aren't that different, just one's a little bit more complicated from the other one. Let's take a look at one radical problems, and like always, let's come over here and get some steps. Step one, we're going to isolate the radical. Step two, we're going to raise both sides to the root or index, whatever you want to call it. Step three, solve whatever's left over. That means it's going to be a brand new type of equation, either linear or polynomial. Step four, if it was an even radical, you need to check your answers. Now, of course, you should always check your answers when you're solving equations, but sometimes you don't have to. As long as you do the work right, it'll always check. However, if it's an even root problem, sometimes you can do all the work correctly and it still won't check. So let me give you a little bit of room here. Let's just try a few of these. Of course, our directions for the rest of this will be solve. Let's say I have the cubed root of 2x plus 3 equals, I don't know, 2. All right, this is a one radical problem because you can see we only have one radical in the problem. So following our steps, isolate that radical. All right, that's done. We got it on a side all by itself. Raise both sides to the root or index. So since this is the cubed root, we want to cube both sides. Now over here, since this is just one radical being cubed, the cubed and the cubed root cancel, and we have 2x plus 3, and of course 2 cubed is 8. Now we need to solve whatever's left over. Well, this is just a linear equation. This seems easy enough to solve. So we get 2x is 5. Divide by 2, we get x is equal to 5 halves. Now, since this was an odd root, we do not need to check, which means as long as our work is right, this will check. Let's take a look at another one. See if I said the square root of x plus 3 plus 8 is equal to 2. But again, this is a one radical problem. As you see, we only have one radical here. So our steps are going to be isolate that radical. So let's get it on the side all by itself. X plus 3 is equal to, it's at -6. Now, since this is the square root, to get rid of the square root, we are going to square both sides. Now, again, here we have one radical being squared, so that's one term, so we square that one thing, we get x plus 3. And over here, we square the -6, we get 36. Now, this is just a linear equation, finish solving, so we get x is equal to 33. Now, before we call this an answer, we do have to check it. Now, you can do this in your head if you want to. This time, I'm actually going to write this out. That would be the square root of 33 plus 3 plus 8, is that equal to 2? Well, that's the square root of 36 plus 8 is at 2. Now, 6 plus 8 is not 2, which means this does not check. So since that does not check, in this case, here we have no solution. Right? Because it was an even root, we had to check our answer. And even though all the work we did was correct, sometimes they just will not check. All right, one radical problems are fairly straightforward. Two radical problems are a bit more difficult. So let's take a look at the two radical problems. Now, the good news for us, for two radical problems, they're always going to just be square roots. So for our two radical, will always be square roots. Now, since there are always going to be square roots, that's how I'm going to write the steps over here. So later on, if you get to a math class where they're not square roots, well, these steps won't work. All right, so step one is going to be isolate one radical. So basically what we're going to do is we're going to treat it like two one radical problems. We're going to isolate one radical, and then we're going to square both sides. Now this step right here is the hard step in these problems. This is generally where we make our mistakes. Step three, see, once we square both sides the first time, we get rid of one radical. So now we have a one radical problem. So we solve it like a one radical problem. Isolate the one radical left. Step four, square both sides again. That'll get rid of the last radical. That means we have a brand new type of problem, so you need to solve whatever's left over. Again, it could be linear, it could be a polynomial. Now, since these are always going to be square roots, we're going to have to always check these problems. All right, let's just try a few again. Our directions haven't changed. Directions are still solved. Let's say if I said the square root of x plus 1 is equal to the square root of x plus 11. All right, this is a two radical problem. So let's follow our steps. Isolate one of the radicals. Well, that's done. That radical on the right-hand side is all by itself. Then it says square both sides. So here's what we're going to square both sides. Now here's where we all make our mistakes, because there's a big difference between the left-hand side and the right-hand side. On the left-hand side here, we have two terms being squared, which means we're going to have to distribute this out. On the right-hand side, that's just one term, one big radical being squared. So on this side, you can just square the square root and it goes away. On the left-hand side, you're probably going to need to do a little bit of side work. That's the square root of x plus 1, square root of x plus 1. And here you need to distribute everything out. Okay? So let's see, if we distribute this out, square root of x times the square root of x is just x. Square root of x times 1 is the square root of x. 1 times the square root of x is the square root of x, and 1 times 1 would be 1. When we combine our like terms, I have x plus 1 and 2 of those square roots of x. So that's what goes on the left-hand side over here. We have x plus 1 plus 2 square roots of x. All right, now notice here we now just have a one radical problem. So what do? We get this radical on the side all by itself. So let's move everything else to the other side. That's 1 plus 2 square roots of x is equal to 11. Subtract 1. So 2 square roots of x is equal to 10. Now at this stage, we have one more step to isolate that radical. Now one more step would be to divide both sides by 2. Now at this stage, if everything on the other side is not divisible by 2, don't divide by it, or you can end up with fractions, and y'all don't like fractions. But since the 10 on the other side is divisible by the 2, I'm going to go ahead and divide both sides by 2. So I get the square root of x is equal to 5. Square both sides again. This one ends up being pretty easy, so this is just x is equal to 25. Now remember, before I put a box around that and check that, since this was an even radical problem, you have to check. So let's see if this thing actually does check. Does the square root of 25 plus 1 equal the square root of 25 plus 11? Well, that's 5 plus 1 is equal to the square root of 36. 6 is equal to 6. All right, so this actually does check, so our answer is x equals 25. All right, let's do one more of these. Maybe a little bit more complicated than this one. Just a little bit more room. Let's say if I gave you the square root of 3x plus 1 minus the square root of x plus 4 is equal to 1. All right, again, this is a two radical problem, so following our steps, the first thing we want to do is isolate one radical. So we need to get one of these two guys on the side all by themselves. Since this one's negative, I'm going to go ahead and move this one to the other side. Doesn't matter though, whichever one you want to move. So I get the square root of 3x plus 1 equals 1 plus the square root of x plus 4. Then we square both sides. Now again, notice the big difference between the two sides. On this side, I have a square root being squared. There's only one term in here, so I can just square that one term, and I end up with 3x plus 1. On this side, I have two terms inside those parentheses. So I need to distribute that out. And you're probably going to want to go over to the side to do this. Square root of what, x plus 4, 1 plus the square root of x plus 4. And start distributing. 1 times 1 is 1. 1 times that square root is just that square root. Plus the square root times 1 is another one of those square roots. The square root times itself goes away, and that's just x plus 4. So combining my like terms, I have an x plus a 1 and a 4 give me a 5, and I have 2 of those square roots. So that's what ends up on the left-hand side here. I have x plus 5 plus 2 square roots of x plus 4. Notice now we only have one radical, so now we need to isolate that. So get everything else to the other side. So x plus 1, 5 plus 2 square roots of x plus 4. Subtract 5 from both sides. So 2x minus 4 is equal to 2 square roots of x plus 4. Again, my last step over here is to divide by whatever's in front of this radical. Since there's a 2 there, I only want to divide everything on the other side by that if it's divisible. So I am actually going to go ahead and divide everything by 2. If that was a 3 out front, I wouldn't want to do this because then I would end up with fractions. So I have x minus 2 is equal to the square root of x plus 4. All right, let's bring that up to the top so we get a little bit more room to work. So I have x minus 2 is equal to the square root of x plus 4. All right, we need to square both sides again. Now on the left-hand side, again, that's 2 terms, so we're going to have to distribute that out. And again, I'll scribble that out here real quick for us. That's x minus 2 times x minus 2. Again, you can use that formula we used this semester. That's x squared minus 2x minus 2x plus 4. So on this side, when we combine our like terms, we had x squared minus 4x plus 4. On the right-hand side, that's only one term, so all you gotta do is just square the square root. All right, so step 5 now, since we got rid of all of our radicals, this is no longer a radical problem. This is a polynomial equation, or quadratic, if you want to think about that. So what we need to do is move everything to one side and try to factor. So I'll do this in a couple of steps. So we get x squared minus 5x plus 4 is equal to 4. So x squared minus 5x is equal to 0. First step in factoring is greatest common factor. There is one. Two things multiplied together equaling 0. One of those needs to be a 0. So we get x is equal to 0, x minus 5 is equal to 0. So we get x is equal to 5. So in this case, you see we have 2 possible answers. We need to check both of them. So we still got a bit of work to do. So let's check x equals 0. So it'll be the square root of 3 times 0 plus 1 minus the square root of 0 plus 4. Does that equal to 1? Well, that's the square root of 1 minus the square root of 4 is equal to 1. 1 minus 2 is equal to 1. That is not true, right? Negative 1 does not equal 1. So the 0 does not check. All right, let's see if we can squeeze the x equals 5 over here. X equals 5. So that would be the square root of 3 times 5 plus 1 minus the square root of 5 plus 1, or plus 4. Does that equal 1? So that's the square root of 15 plus 1 minus the square root of 9. Does that equal 1? 16 minus the square root of 9 equal 1. 4 minus 3 does equal 1. Okay, so in this case, our x equals 5 does check. So we had 2 possible solutions, but only one works. So solving 2 radical problems, as you see, can be a whole bunch of work. So make sure you're following your steps. You know what you're doing each step along the way, or you're going to get lost. And remember, if you're squaring something that has more than one term, like at this step or over here at this step, you have to go over to the side and distribute out all the terms.